We welcome everyone. Thank you so much for joining us. Go ahead, Tim.
Thanks, Stacey, appreciate it. And what I want to do is I'm going to give a quick introduction, then I'm going to get Ishaan to introduce himself and turn it over to Ishaan. So I'm Tim Faulkes. I'm the Chief Developer Advocate at Aerospike. I run the technical side of it. And basically, my job is to go and talk to developers like yourselves and explain how Aerospike works, look at any questions, any concerns, help do data modeling, anything like that. So making sure that people are very successful with Aerospike from a developer perspective. Ishaan, over to yourself.
Thanks, Tim. Hey, everyone. I'm Ishaan Biswas. I'm a Director of Product Management here at Aerospike. I'm primarily responsible for Aerospike Graph from product perspective. I'm happy to be here and talk about graphs and graph data modeling in Aerospike Graph in this session today. So here are some things we'll cover in the next hour or so. So we'll talk about graph databases and graph data model and Aerospike Graph, all kind of mushed into one. Then we'll talk a little about what graph data modeling is and what are some things you might want to consider when you're starting out building an application using a graph database. Then Tim will actually walk us through building an application using graph data with a very representative real-world scenario that many of our customers today use. And he'll also actually compare and contrast with the same implementation using Aerospike as a key value store. And so if you're considering, hey, why should I use Aerospike Graph and why can't I build this myself? I think that part of the discussion will really drive home some key points for you and make that decision pretty clear. So with that, what are graph databases and why are we talking about graph databases? So for many of you on this call, this might be very beginner information, but just to kind of lay the groundwork and make sure we're all on the same page, graph databases are just another type of database, specifically a NoSQL database. The direct comparison with the relational model is primarily because of relationships. So when in this small example, you have a product listing and you're modeling that you can model that in a relational database where you'd model a product based on in a row format. We'll have product and price and categories and descriptions and everything about the product listed as rows. And that can be really powerful for some kinds of use cases. For other kind of use cases, especially when it comes to recommendations, finding co-purchasing patterns and things like that, it becomes a lot easier to do this using a graph database. Now, there are pros and cons of either approach. What we're doing here is providing you with as much information as possible so that you can make the choice for yourself. A graph database captures dependencies and relationships between the data points. And it becomes the key differentiator between a graph database and any other kind of database, whether it's a SQL database or a SQL database, is that relationships or edges are explicit entities that are stored in the data in the disk itself. So relationships are actually first-class citizens. What that means is the data is pre-joined at load time. So whether you're bulk loading the data or you're writing the data or streaming your data into the database, the join happens at the time that you write so that when you're querying it, you don't have to pay the penalty of join. So as we all know, joins are really expensive. And so graphs really alleviate that problem. The other really good thing about graph databases is that you can query the data with a model native query language. What that means is the way you think about the graph data model and the way you think about your application and how it's using graphs, your queries very closely mimic that thinking. So you don't have to do this translation between how you're thinking about your data versus how you're accessing the data in the database. So now the next natural question is, when should you use graphs? Now, this is not an exhaustive list by any means, but these are just some general guidelines that'll help you point in the direction whether a graph is a good fit for your use case or not. So first is, there are lots of relationships in your data model, and your query patterns require traversing over those relationships. So if that is a characteristic in your application or in your business logic, then a graph database or a graph data model might be a good fit for your use case. The other thing is your data model might be constantly evolving. In that case, also a graph might be a good fit because it's really easy to modify the schema and still have the similar query patterns work on that same data set. Now, the other couple of key things is like if you're considering a graph data model, you can also do similar things with a relational database, or in fact, even a key value for that matter. Both of them, again, have their pros and cons. So modeling your data, if you're modeling your data in relational system, require a lot of joins, that again would be a good fit for you to look towards graph. And the other side, if you're considering, and in many cases in this audience, if you're already an Aerospike user, you might be thinking, hey, I might just model Aerospike as my data as and use Aerospike as a key value, and not use a graph database altogether. That would limit the flexibility of what you can do and massively increase the complexity. And we'll actually get into the nitty-gritties of this later on in this session. Another thing to consider or a characteristic to look out for in your use case is, are you trying to integrate many disparate data sources which are heterogeneous in nature and use that data when you're making a decision about an individual or any decision about your use case? That is, again, a good reason to use a graph. And again, is there a need for you to visualize the data? That's another reason to consider a graph. So with that, well, let's get into where do these characteristics, what are the industry verticals where these characteristics fit really well? So one is identity graphs in the advertising tech ecosystem. Whether you're doing targeted advertising or real-time bidding, identity graphs are crucial and you are very predominantly used by many companies and organizations in this ecosystem. So that's a very natural use case for graphs. Similarly, doing customer 360 across industries, whether it's any large enterprise, really, whether it's a telco or an e-commerce or a retail operation, a graph might be a good fit. And more specifically, Aerospike Graph is a good fit because there's a lot of data involved and really high throughput required for some of these use cases. Another one in the financial sector is around real-time fraud detection or prevention, both in the financial service industry and in e-commerce. So with that, let's talk about what Aerospike Graph is and what does it look like. So we'll make the assumption that many of you here, or most of you here, are familiar with Aerospike. Aerospike Graph is essentially a graph interface on top of the database. So the product consists of two pieces. With the storage layer is the database. So that's the Aerospike database cluster on your right. And then there are Aerospike Graph service instances. That's the boxes in the middle. That provides the graph interface to the database. The way you use it is by integrating the query language within your application. We currently support Gremlin out of the box. So you can integrate Gremlin queries within your application, point them to one or more Aerospike Graph service instances, and run your applications. And all of the magic behind converting those queries into the underlying Aerospike API is done by the Aerospike Graph service instances. What you also see here is Apache Tinkerpop. So we leverage the Apache Tinkerpop project to do the graph compute, the graph computing. And this is where we integrate the Aerospike client API. So this is where we've done a lot of work in using advanced features of the database to optimize for performance. So what the other interesting thing that comes out of this architecture then is that you can independently scale both compute and storage. So Aerospike database based on the data volume and the overall throughput that your database needs, you can scale that up and out. And that works pretty seamlessly. And that's a very mature database that's been in development over almost more than a decade now. On the graph side of things, based on the throughputs that your application needs, you can scale up, you can scale out or scale in the graph service instances. So since these are stateless compute engines, you can scale these pretty elastically based on your application needs. So what this then means is, from a hardware perspective, you're very efficiently utilizing your hardware resources, which eventually leads to a massive TCO advantage. Next slide, please. So now, if you're an admin, what does that mean for you? So if you can independently have an infrastructure where you can independently scale compute or storage, that means you can use your hardware efficiently, which again then means that you can have a lower TCO. And given Aerospike's inherent TCO advantage for storing data, that you can leverage for graph as well. So that means that we have been able to provide an industry-leading TCO model for graph databases. And the other important point here, especially for admins, is you can use a single vendor, when being Aerospike, for different kinds of application data models, whether it's key value or document or graph. You can use the same database, have separate namespaces, but have the same database cluster for different application needs. So that means you don't have to have 3 different vendors that are optimized for specific data models. So all of this greatly simplifies your job as a database admin. For developers, I'm guessing most of you here fall in this bucket. For developers, we made things really, really straightforward for you, and you'll see many examples of this in this session. The first is you get to talk to the database using a graph native query language. What this means is that your business logic or your application logic that you're writing, you write that as Gremlin queries, and you express that with your application needs in mind, not with the database needs in mind. That greatly simplifies the cognitive load on your head when you're designing your application. The other thing is, Aerospike, as you know, is known for its real-time performance and really large throughput for really large data volumes, and that same applies to graphs. So now you don't have to worry whether when you're using a graph database, you don't have to make a choice. So you can still use large data volumes, get large amounts of throughput, and predictable low latencies. And the third is, you can, if your use case requires to bulk load or batch load data in large amounts of data, we have you covered when you're starting out and also when you're going into production. So we have a beginner-friendly bulk load that's integrated into the Gremlin client, but also we have a Spark native bulk loader. So if you have a large Spark cluster and that's where you're building your graph or constructing the relationships, you can use that to feed that data into Aerospike Graph. So with that, let's talk about a simple application. I'll hand it over to my friend Tim here, and he'll go over an example and how do you model this and go into the nitty-gritties of writing an application using Aerospike Graph.
Thanks, Ishaan. So to give you a bit of background about myself, I've spent more decades than I'm willing to admit in public writing applications, typically financial services and typically with relational databases. Recently, obviously, in the last 8 years or so, I've been around NoSQL and using Aerospike and other NoSQL databases to test things. So this was actually my first foray into graph, and I was very interested to see how it would perform. I distinctly remember having relationships in all those scenarios. I've had one project I worked on for financial services where we had an entity relationship diagram. It covered an entire A3 sheet of paper. For those who don't speak metric, that's a big bit of paper. Very small font, and it showed a very complex graph. In Aerospike, we obviously spend a lot of time doing things like real-time decisioning, getting information from many different sources and trying to work out, is it fraudulent? Is there a problem in a manufacturing pipeline? Doing things like that and doing it in real time. And all of that requires interrelationships. So when we released the Graph product, I was very excited to be able to play with it and say, all right, let's look at some common problems that we've addressed in the real world. And so the one I'm going to pick on today is an ad tech use case. Now, in ad tech, I'm showing something on my browser, and there's a bit of space that someone says, I want to show an ad. And it goes into a competing bidding war, effectively between the ad tech providers to say, well, what are we going to show Tim on that bit of space? And the best way they can do that is they can look up everything they know about my device, work out what sort of things they've seen me purchase or buy recently, and say, well, I've got something that's similar and they've got a special on, he might be willing to buy on that. So they might be willing to bid a bit more for that space on my screen. So it's very common. Now, that's a very simple way of doing it. They're just looking at the device and storing things on the device. But more often, what they'll do is they'll form a picture of not just the device, but who owns the device. So I might have an iPad and an iPhone and 16 computers, being me. They all have browsers on. They might want to try and amalgamate them all down to me, or what they think is me, so that they can bid across it. They might also realize that my wife and I share a computer or a device or something like that. So it might not be me who's actually running the device. It might be someone in my household. So what they tend to do is have these complex graphs that look something like this thing on the right, where I have a person who has multiple devices. A person belongs to a household, and multiple people will typically live in the same households. It's entirely possible that a device is shared between people in different households too. And those people have interests, and the interests are the things that they really care about. It's things that I'm interested in that I might bid on. So this is the graph I'm going to be recreating and looking at the performance and how it solves the problem. And effectively what I want to do is I've got this complex graph and I've got a device 2, and I'm using a browser on that device. It has space to show an ad. They want to be able to know what the interests are for anyone in this household so that they can work out what sort of ads to show. So to understand graph, the first thing you have to understand is the data model. And graph is slightly different. As I mentioned, with relational databases, you've got inherent relationships. You've got foreign keys and primary keys and things like that. They model relationships between different entities, but they're not first-class citizens. It's a basic reference between two different tables. With graph, you store information in vertices, and those vertices will have edges. The edges are the relationships between multiple vertices. A vertex and an edge can both have properties. The properties are key value pairs. So a vertex might be, say, a customer, and a customer might have a name, it might have an address, things like that. But the edge might be a relationship between two different vertices. It might be a timestamp or something which says, I've got a customer has an account. Those would be two different vertices. And the edge attribute might be, what sort of account is it? When did I create that, that relationship between the account and the customer? Information that is pertinent to the edge. So it's a first-class citizen of the data model rather than being sort of a derived entity that is typical in relational systems. Now, this gives us a lot of flexibility, and traversing these relationships and forming these relationships gives us a lot of power and flexibility across the data model. So we've got a schema. So I've got vertices. In this case, the data model you can see is down below. So I have people or person. I've got 3 of those. It's a very simple data model that I've done just for illustrative purposes, but you can see that I've put a first name on the person. I've got a device. I don't have any properties on the devices. I've got a household, which has a name like the Faulkes household. And then I've got my interest. What is my interest? I've got a name which describes what that interest is. These are all vertices in the graph. I've got different edges. The edges have a name or a label, which says, this is what I want this to be known as. Vertices can also have a label to say, this is a person. So typically the vertex type is a label. And I can create these relationships and traverse these relationships as I'm going through the graph. So as I said, I haven't done a lot of graph before. I was very interested to play with this. And so what I'm going to go through now is some of the results of my findings, having played with extensively with relational databases and Aerospike, to talk to you about what the pros and cons of graphs are and how I found modeling it. So a refresher from Ishaan's slide, we have this architecture. Now, in my case, I'm running everything on my laptop. I'm not expecting great performance. I've got a Java program running in my IDE on the left, so one app. I'm running against a Docker container, which contains the graph service, and it's talking to an Aerospike database. And because I'm running on a Mac, that database is also running in a Docker container. So in my case, I've got one of each of these components. I'm not expecting stellar performance. I did do some performance tests on a more beefy machine, which I'll talk about later. But it was just getting the concepts down pat. So if you look at graph, what most people do is the queries tend to be the important things. They're the things that people really want to focus on. And so a lot of the tutorials and things you find are, how do I query the data? Here's a really big data set. And if you look on our website, for example, we show you how in a single line to import a whole bunch of traffic routes between different airports. And you can get in a very, very big data set very quickly using a single command. And then there's lots of information on how to query them. But to me as a developer, the first thing I want to know is, how do I build this up from scratch? I don't want to start with an existing database. I want to create my own. And so the first thing I'm going to do is insert some data. And so when we do this, the first thing we do is we create a traversal. The syntax here is standard Java, but it looks a bit different. It's very functional, if you will. So I create a traversal and I tell it where my database is. So I give it a remote driver connection, and I'm using my Docker container IP address 172.17.03, and the port that I'm talking on 8182. Now, the thing to note is this is not my Aerospike database. As we mentioned on the previous slide, my application does not talk directly to Aerospike. Instead, it talks to the Aerospike Graph service. And that's the IP address that I've given it here. This is the Docker container of the Graph service and the port of the Graph service. That Graph service I've set up so it's going to go and talk to the Aerospike database, but my application won't talk directly to the database. Once I've got that set up, the first thing I need to do is set up a single vertex. And so I create a vertex, and it's a simple call to add vertex, and I give it a label. A label is a name that, pardon me, it's optional, but it's sort of like a table description. It says, what is the type of this node? So if I had multiple households, I would give them all the same label. So it's easy for me to say, how many households are there? How many people are there? And so on. I can then go and set different properties on them. So in my case, I've set the family name to be Jones. And then I've done next. Now, next was a bit odd. When I started doing this, I didn't realize the need for next. And so I said, I'm going to create my vertex, put a property on it, and I'm done. But then it said, well, I don't know what to do now. And the reason for this is I can chain multiple operations together. If I look at the bottom piece, I create a vertex. It's a person in this case, and I'm setting multiple properties. All of this is part of one traversal. I can not only set properties, I can add other vertices, other edges. I can do a whole bunch of things in a single statement. And that traversal terminator is basically saying, I am done. So every operation that you do that starts with the G, which is our traversal operator, returns a traversal. What you want to do is terminate those at some point. The traversal is not complete. It won't go and form those relationships until you've called that terminator. And so there's different traversal operations. I can add filters, I can add properties, I can do aggregations. As I said, there's an awful lot of these operations. To terminate them, I can do next. That will return a single result. If I'm getting a list, I can do iterate to iterate over the list, or I can do toList to get a list as a result, and so on. So you'll see that each of the statements that I'm going to present will end in some form of a terminator to tell Aerospike Graph Service, hey, I want you to go and apply this onto the database. Go and save this information into the database. All right, so I've got my vertices. That was easy. I did an add v. All right, so I now want to create relationships between them. So let's say I've got two people, Bob and Amy, and they know each other. It's a very generic sort of statement. So I'm going to create two vertices, v1, v2, and I do an add v. I give it a property of first name of Bob and call next. Same thing for Amy, call next. I get my two vertices out. Notice next is returning a single result. In this case, I've only created one vertex, so I can get a single result, and that works just great. But then to go and create the edge, I can go and tell it that I've got vertex 1, so my graph traversal, create vertex, grab vertex 1, add an edge of nose to vertex 2, and then call next to finish that statement. So it's really very intuitive coding. It's very, very self-explanatory about how do I go and form these edges. Now, this is good, but I found it to get a bit verbose. But what I discovered was you can do aliasing. So in one statement, I can go and do the same thing. I can create a person edge, Bob Jones, age 27, but then I'm going to tell it that I want an alias for this vertex. So this person is going to be person A. I'm going to add another person, in this case, Amy Smith, and they're going to be person B. And then I'm going to add an edge of nose from person A to person B. Very intuitive. It's really easy to read the program. It's really easy to look at it and understand exactly what it's doing, even if you're not necessarily familiar with the Gremlin query language as it is. So that big messy graph, which included the households and the people, the devices, the interests, I went and finished that off. So I said, okay, I've got my add vertex on my household. I've got properties on that. I create my property, my household. And then I went through and added all the people, all the devices, all the interests, and so on. After I finished creating all my vertices, I went and added the edges. Now, I didn't have to do that in that order. It just seemed cleaner to do it in that order. But this was effectively a single statement. So yes, it's a big statement, but that big graph that I formed can be formed in a single statement. Now, obviously, in a real development environment, you probably wouldn't do that. You'd be adding things and removing things over time. But it just goes to show the power and flexibility of the language. Once I formed that, I found that there's a tool out there called G.V. And G.V is a query engine for Gremlin. And so I ran G.V against my database. Now, remember, this is an Aerospike database, and it has the Aerospike Graph service in the front acting as the Gremlin translation layer. And all I had to do was point G.V at my Aerospike Graph service, and it went and found all the people, all the relationships, and gave me a visual diagram. Now, in this case, I didn't clean it up very much. I could have reorganized the graph, but I can certainly set it up and move things around and play interactively with it. It can also show me the schema. So that schema I showed you earlier, that was all generated out of G.V. So the visualization tools that come out of Graph and the fact that I can just run queries inside G.V or the Gremlin console, which comes as a standard part of Gremlin, means that I have a lot of different ways of querying and manipulating the data in a fashion that is very, very easy. So let's look at our query. We've formed this graph and we did so through that single statement that I showed anywhere. Now, our business query said, given an impression on device 2, find the interests of anyone in the household. So how did I model this? Well, the first thing I want to do is obviously I want to select device 2. So I said G.V has device with an ID of 2. That first device is a label. And so I've labeled all my devices as a device. And that's basically like the table name, if you will. And so this says, go and find me any device with an ID of 2. Once I've got that, I want to find anyone who uses the devices. Now, in Gremlin, our relationships are unidirectional. They're one directional. So person 1 owns a device. If I wanted to device 2 to point to a person, I'd have to create a second relationship. However, you can find the outgoing and the incoming. So I've got device 2, and I want to find the incoming relationships. So even though person 1 refers to device 2 knows that it's got an incoming edge from person 1 and an incoming edge from person 2. So a simple in call will go and get me both those people in one single statement. I can also filter it out further. Now, I've done the same thing going up to the next level, going from the person I want to find any incoming relationships. And I've said I only want them ones where it's a member. So household has a member relation to people, and I only want to follow those members. Now, in this case, I didn't need to do it. There's no other incoming edges into these people, but I wanted to show it for illustrative purposes, that this member, that I could say, even if these people had relationships between them, I only cared about the household. In member would guarantee that I only get the ones where I have a member coming in on that edge. That gives me the household. I now need to go and find all the people. So I'm going to do an out, because the household has an out direction to the people of anyone that is a member, and that will give me those 3 people. From there, I want to get their interests. So each one of these people has multiple outgoing relationships. They've got relationships to devices as well as interests. So in this case, I do have to filter it down. So I'm going to say, I want an outgoing edge, and the relationship is has. So a person has interests. And that gives me all the interests. Well, that's good, but I don't really want the interests. I want the name of that interest. So if you remember the data model, each one of those interests has a property name. And that property name is the interest that I care about, be it sports or cricket or computers or whatever. Now, that's good, but I've got 2 people who have the same interests. I haven't told it whether I want duplicates or not, and by default, it's going to give me duplicates. So my last statement is going to be dedupe to say, I don't want 2 copies of interest 2, I just want 1 copy. And so in one statement, I've gone and solved this problem. It's a slightly complex statement, but when you look at the graph and you can see a visual representation either through the screen or through that g.v that I spoke about earlier, you can traverse it in your mind and see exactly what's going on. It's very, very intuitive to read. So I'm a bit of a sucker for punishment. I said, okay, this looks good. This looks really good. But what if I was doing this in Aerospike? What's the difference in complexities? I want to model this also in Aerospike native key value and see where the differences lie. So in my Aerospike, I had 3 different sets. I had my household set, I had my person set, and I had my device set. And obviously, Aerospike doesn't model foreign keys for me or anything like that. So I had to do that manually. Not a big drama, it's something we do very commonly in Aerospike key value. But I found that my person needed to have its household ID. I know that my household needed to have its members. The devices, I needed to know their IDs. The devices need to know the user IDs. So it's keeping these bidirectional users both ways. And so I wanted to make sure that it's a representative data model. It's very similar to what I did before. And then I went and coded it. So when I created the model, relationships are bidirectional. So I need to enter an ID at different ends. If I want to insert an edge between A and B, because I need to go both the in and out direction in this, I need to say, I need to insert from A to B, and I also need to store B's key in A. It's both directions. Whereas in Graph, all I had to do was specify one edge, and it took care of all that for me. The collections I've modeled as maps rather than lists. In this case, they probably could have been lists, but in a real life scenario, I would have modeled them as maps so that I could store those attributes if there were any on those relationships. And in particular, something like a person with their interests, I might have put a time to live as a relationship on that, or some form of an expiry. So I know after a given period of time, I don't want to consider that relationship. I'd need to do that explicitly using a map, whereas Graph would just be a property on that attribute. The total lines of code for this was about 60. And I'm showing it to you in all its glory. I'll bring it up in my IDE because it shows it a bit better. So those 60 lines, sorry, 60 lines are very repetitive. I'm creating my lists and inserting something. I'm creating more lists and inserting something. I'm creating maps and inserting things. So it goes over and over, and it's a very verbose syntax, as we're all used to. I create a new bin, I create a new bin, I create a new bin, I can create a whole bunch of bins. But all this code is simply forming that data model, that same data model that I did in one line before. Okay, what about retrieval? Well, Retrieval wasn't quite so easy. I'm going to jump back to my Eclipse. And when we retrieve, we have to do a whole bunch of work. We've got to go from device to the users. We have to get from the device to the, people to the household. And all those steps, it's fairly painful. Because I've got multiple things, I've been using a lot of streams, but I look at this code, and I wrote this code not long ago, and I'm getting lost in it. It's not simple code to do it. It can all be done. This is all Java code. And so it's complex. It's using streams. It works, but it's very difficult to do. Now, just to prove it works, I'm going to jump back to my version of the graph, and I'm just going to run this. So if I say run as Java application, okay, it goes and creates a cluster. The first thing I do is delete the cluster. It goes and forms all my relationships with my one statement, and then it does my one graph traversal. And you can see that I get all the results that I'm expecting. The same thing works in Aerospike too, obviously. So just jump back to my presentation. All right, so what did I learn? Obviously, in Aerospike, the code complexity is very high. There's about 30 lines of data for one simple traversal rather than one for the graph. Intuitively, it's much harder to read native key value Aerospike than it is to read the graph syntax. And as I said, I've been using Aerospike for a very long time. I know it very well. And so I find it difficult to read. It's a lot of data. It's a lot of extra steps. In terms of maintainability, the key value implementation is tied very, very closely to the problem I'm solving. If my data requirements changed or my business requirements changed, it would have been harder for me to change. With Graph, it's really easy. If I was using a relational database, again, the relationships are difficult to change, but also because it's schema-based and I have to put a structure in on that, it's difficult to add new columns and change things. With Graph, it's schemaless. And so it's really easy to adapt a data model to changing business requirements. So going back to the propositions for developers, and I focus on developers because fundamentally I've been a developer for most of my life. I didn't know Gremlin. I got a learning curve. It took a little bit of time. The nice thing is there's a free online book about Gremlin. I found it very, very useful. I didn't read it all. I got enough to be dangerous. And I'll give you a link to that at the end of this presentation. But I found the language itself was remarkably easy to pick up. I'm sure there's a bunch of nuances that I've missed, but just for a beginner entry, it's very easy. And the business logics are intuitive. I can look at it and say, yes, that matches my use case. I can go and change it if I need. Doing the Aerospike side of things, it wasn't easy for me, even as the author of the code and someone who's very familiar with Aerospike, to look at it and say, I can see exactly how this solves the business problem. The fact that I can visualize the data was huge. The fact that I can just load up and have a look at it and say, and run a query even in that g.v tool or the Gremlin console and manipulate things on the fly was very, very useful. I didn't do the bulk loading. I did one of the loading up the data and it was very easy. It was one line, but I didn't play with that extensively. I was more focused on building this and creating things myself. Now, one of the things I haven't touched on in a slide is performance. I ran these on my laptop and figured it wasn't a fair comparison. There's a lot of things happening on my laptop. So I put it on a reasonable server, both the Aerospike version with the native key value and the Aerospike with the graph. And the performance on the same query was pretty comparable. I think the entire query on the graph took about 2.5 milliseconds. And remember, that's going up and loading up a whole bunch of entities and traversing edges and things like that. And the one on native key value was just under a millisecond. Now, there's overhead there. I've got an extra network hop. I'm going from Aerospike program to the graph service and then onto the database. So there's an extra network hop in there. There's also complexities. That graph service is written in Java, and there's some fixed overhead of starting that up and demarshalling and marshalling the different inputs. So I would expect if I was to go into a bigger, more complex query, that the overhead would remain moderately fixed rather than having that multiplication effect across the number of times. So I was pretty impressed with the performance, to be quite honest. As Ishaan mentioned, there's lots of value propositions for admin. It's easy to scale independently because the compute is now separated from the storage. You can scale them independently. If you wanted to run more complex Gremlin queries, you add more Gremlin nodes. If you want to scale the database and store more data and have more throughput, you can scale the database. So that's very easy to scale independently. It's a lower total cost of ownership. Aerospike is renowned for this for many reasons. And we use the power of the Aerospike database to run the graph on top of it. And that gives us a huge amount of flexibility and power. And that low TCO that comes with Aerospike naturally applies obviously to graph. And I personally like having one database that will do multiple things. It simplifies the ecosystem. So hopefully this webinar has sparked some interest and you've got some interest to say, hey, I like this graph service. It seems kind of cool. I want to go and play with it. All right, well, here's a link to go and get started. Download it, have a play with it. Would love to get your feedback and know what you think. If you want to find out about Gremlin, as I mentioned, there's a great book. We've got a link here, a QR code to it. It's online, it's free, and it's very well written, to be quite honest. I hope this has been useful for you. We have got a large focus on developers now. And one of the things that we're trying to do is push a developer community. So if you're a developer or someone else who's interested in technical things and doesn't want to be marketed to, come and talk to us. We're on Discord and it's a developer-to-developer style chat. If you've got questions about Aerospike or how to use it or anything like that, we'd love to hear from you. And so we've got a growing community on Discord. If you want to have a look at some of the code samples, some of the technical information about Aerospike Graph and how it's set up and introductory things, and it's very comprehensive actually. It starts off loading a data set and showing you how to get a program up and running and not just using the terminals, but also having actual programs running against it. Come and look on Aerospike developers or Aerospike documentation.
Awesome.
So I was just going to turn it over to you, Stacey.
Yep. Go ahead and finish up, Tim. I was just going to refer back to a couple of questions here.
I've finished up and I was going to turn over to you and ask if there were any questions.
Great minds think alike. So I'm going to go back and answer a couple of questions backwards here. There was a question about TCO and what that is. It's total cost of ownership. And there's just some terminology acronyms in the question box that I'm going to respond to. Right.
If I can respond to that a little bit more, I noticed there was a follow-up on that. So what does TCO or total cost of ownership actually means? What it means is how much are you, as an organization, what does it cost you to own a solution? This includes how much is your hardware infrastructure, how much are you spending on the software license, how many people does it take to support it, to operate for operational reasons. It includes all of that. So if you put your business hat on, whoever is responsible for running the service, that person has to spend a certain amount of money to keep the service operational. That's what TCO or total cost of ownership measures.
That's absolutely correct. Thank you so much, Ishaan, for expanding on that. Because we've got a couple of questions on that. I'd also like to go back, Tim, when you were in your live code sample there, when you were walking through that code, people were asking what type of code is it? Is it C code, C++? Do you want to expand on that?
Pure Java code. So C is even harder to read than the Java code, I find, but I'm a long-time Java programmer.
Right, and furthermore on that, would it support JavaScript?
Well, the Gremlin protocol is transparent, but we have libraries. And Ishaan, which libraries do we have at the moment? I know we've got Java, we've got Python too, don't we? Is that correct?
Yeah, so Gremlin has a very strong ecosystem of what's called Gremlin language variants. So these are language-specific drivers for Gremlin. So there's a Java one, there's a Python one. I'm pretty sure there is a JavaScript one. I'll have to look that one up. But these are all drivers built idiomatically in the language that the driver is for. So it's very intuitive. If you're a Python developer, it'll be intuitive for you to use the Gremlin Python driver, for instance.
And given the prevalence of Node.js these days, I'd be stunned if there wasn't a Gremlin driver for Node.js.
Right.
Right.
So then furthermore, the code that you used in the demo created vertex edges, et cetera. When someone else is running this single statement, is it atomic?
At the moment, no. So at the moment, we are storing these in different sets or tables. They're in different records. Otherwise, one record would get too complex. You couldn't store a big graph in it. So at the moment, they're being stored in different records, which would be the logical way of doing it. We don't currently support multi-record transactions. So each key value is independent and therefore it is not atomic. However, we do have on our roadmap multi-record transactions. Once that arrives, then we'll probably look at making these atomic. So a single statement is atomic. But that's
Okay. Let me go into a couple other questions here that we have. How do we know to model a person in the example data model? Wouldn't it be something like an email address?
So one of the things that I actually forgot to say is there's a whole bunch of different ways of modeling things. And I'm going to jump back to that relationship slide because let me go to the simple version of this. This is how I decided to model it. But like any problem, there's different ways of solving the same problem. I could have had the interests inside the person. I could have had, a different way of modeling this. Instead of having two people sharing the same interest, I could have had them having their own interest with the same name. So there's no necessary right or wrong way of modeling. It's based on your particular use case and what solves your business problems. One of the things to note is that when I'm creating these, I don't give them primary keys. I don't need to. The graph service will maintain the keys for me. So if I want to go and look someone up, in this case, I wanted to look up a device too. So I said, go and look up a device with an ID of 2. Now, there are ways of using Aerospike's primary keys. It's a bit more complex, so I didn't want to cover it here. But if you don't maintain the keys, Aerospike Graph will look things up through secondary indexes and things like that to make sure it's an efficient retrieval. If you do want to use IDs, then there is a way called t.id, which allows you to model it using a primary key as well.
OLTP, which it stands for online transaction processing, but someone's asking, what is the OLTP graph query?
So effectively, there's 2 different sorts of database queries you can have. OLTP, which is designed for a small query done in real time. So it's online transaction processing. It's very fast. It's typically something which should complete in a few milliseconds. The other one is OLAP, the Online Analytics Protocol, where you have large queries across massive graphs, which can take minutes, hours, days, or longer. And really what we've designed Aerospike Graph for is an OLTP style queries where they're short and sweet and run very, very quickly. And they work really well. Ishaan, is there anything you want to add to that?
Sorry, I was reading the next question.
OLTP
graph. Okay, so yeah, in the graph context, what OLTP graph query means is, since graph is unlike a key value or relation where it's row-based, graph is just a bunch of data connected together, right? So you need to know what the starting point is for your traversal. So an OLTP graph query means that you know your starting point, so you can find your starting point, and then you traverse over the neighborhood of that starting vertex. Versus an OLAP would be like, give me all the, like in Tim's example, it'll be like, give me all the people who have an interest in sports cars. So that in that query, you have to traverse over the entire graph and find and do an aggregation. So that's something that we don't support today. That it's something we will support within the next few quarters, but that's what we mean by OLTP queries. Short pointed queries where you know where you need to get to and you need a response really, really fast.
Okay, excellent. We've got some really good questions here and we'll try and get through all of these before the top of the hour. Bill Reynolds, I think that you were asking a question regarding an end user report listing people and each of their devices. Perhaps that's the one you were reading, Ishaan. As you point out, the graph query is super easy versus coding Java, and that's just to reiterate over the raw data versus the formatting, et cetera. What do you see application developers using through to traditional reporting tools that have no Gremlin smarts? So it's a bit of a typo there, but
okay.
If you're on that, Tim.
Yeah, so to me, there is no perfect database. Every use case has different requirements, and sometimes you have to pick the database that meets those requirements. If you're using SQL-based reporting tools and you need to be able to get at your data through a SQL interface, typically a graph interface is not going to work well for you. There's differences in the semantics, and the way we store the information in the database is optimal for graph traversal, but it's not very useful or friendly for SQL traversal. And so if I had to use SQL reporting, then graph might be a bit of a stretch. If I was able to use a graph-based query tool that spoke Gremlin, then obviously graph would be far easier to use. So like any use case, I would always advocate you pick the right tool for the right job. And graph is good in many use cases, but it's not good for everything. So look at what your requirements are, and SQL reporting is one thing which would definitely be a factor, and work it out. If there were requirements to just do the SQL reporting and graph was a perfect fit for everything else, then there would be other ways I would look at doing it. I might look at storing a copy in a database that is more SQL friendly, in a different format as well, or something along those lines. But it really comes down to what your requirements are.
Okay. And great. And then how does it work for transactional based systems?
So I think we answered that already, in that at the moment we're not transactional. So it will work, but you do have to be a bit careful. We can't guarantee atomicity across multiple records at this point in time, but that is coming.
Okay. We've got another question regarding what will the performance be like with string type PK, and will we be able to get a count from graph queries that is generally done during debugging? I think there's some words missing in that, but if you guys can read that maybe and respond.
Let me take the second part of it as well. So the performance for a string type primary key, we haven't found any performance differences. We haven't specifically tested if it's a string type key versus a numeric key. We support both. And in some of our internal benchmarking, we haven't really seen any difference or a substantially performance degradation, specifically if you use a string type ID. Will we be able to get a count type operation from graph queries? So that's actually an good question. So counts are generally expensive because you have to do a scan of your full data. What we have actually with Aerospike Graph is we maintain a running count of all vertex types and edge types and different metadata about your graph. And so without running a count, using a simple command, you can get your graph summary statistics. So I'll put in a link to our documentation page, which has the details on this, but this definitely supported. In fact, in Tim's, actually, Tim, if you can go back to your data model slide. I think that was this one. So if you see here in the data model, it actually does show the counts. So we have an integration with g.v already, where you explore, if you use the data model explorer there, you'll see the counts as well. So especially when you're debugging things, this is definitely helpful and is supported as well.
And actually, if you don't mind, I'm going to jump in because I forgot something that was very important. So it was a great question that was just asked. And in my data model, I actually have different types. So I can see I've got some device IDs have a integer ID and some that have a string ID. one of the things that I forgot to show is, what if I want to know what its performance is like? I mean, if I'm using Aerospike key value, I'd have to go and time things myself. But in my Gremlin query, I can simply do that and put in profile. He says as it, okay, I've got to change my type. Just make a list. I'm going to be very lazy for the moment. And then I'm going to just print out my results. And then I'm not going to do, I'm just going to comment this out. So if I was to run this now, same code, and I just run that as a Java application. And, sorry, let me just bring that up full bigger so we can see what happened. You can see that it's now giving me my traversal metrics. Where did it spend the time? What was it doing? So you don't have any capabilities of doing this inside native Aerospike. You can, because it's multiple steps, you can do each step yourself. But running a query, you can do, it's more like an explain in a SQL process, which shows where the time is spent. And if you need to optimize things, what steps you need to optimize. So I found that very, very useful. I've neglected to mention that. Apologies about that.
So an associated point here, I know we're almost at time, but with G.V is a Gremlin IDE. So what you can do there is also when you're writing your Gremlin code, you can step through your Gremlin query and it'll run parts of the query. So that's super helpful when you're figuring out what your Gremlin query should be and you don't exactly know how to navigate your graph. You can play around with it, run just parts of the query, see how it, and get partial responses and build on top of that. So those kinds of things are just not possible with just using Aerospike natively as a key value store. So if you have a graph use case, all of these additional tools that come with supporting a standard query language come with it.
Okay. Someone is requesting, I want the implementation of graph code in Java. Where is it in your GitHub? Please send or please post.
Okay, it's not there yet. It will be on Aerospike examples. I'll put it up there before the end of the week. If you can't find it, then please come and reach out. If you want it quicker, the best way is come and join our Discord community and just send me a message and I'll Slack it to you directly or Discord it to you directly. Yeah, I'll put it up on the code before, sorry, the GitHub Aerospike examples before the end of the week.
Awesome. And then we had a nice compliment. Thank you so much. We appreciate the compliments and then the presentation, and it was helpful to understand Aerospike database and Aerospike graph. So this is really beneficial for us to hear the feedback as well. And Discord is the place to tell us. We want to hear about any challenges or questions that you're having. We always love to hear positive feedback of what's working for you. And we're happy to direct you any tools or resources that we have. We're always there to help. Please, I'm encouraging you to join that and reach out to us. We make it kind of fun. It's a little bit more casual. So hope you can join us there. I did post a poll here today. I just want to throw that out there. We have a trial of Aerospike Graph, open source community edition. We can put that together for you and give you a link. We'll do that in some of our post communications because I see some people did not have that and maybe that would be beneficial to you. And we appreciate, again, the response to whether or not our session was helpful today. And more information, again, reach out to our Discord community, reach out to us at developer@aerospike.com. You can always reach out to me personally. I'll get you to the right person. I'm all over social and especially LinkedIn, skruzik@aerospike.com. Happy to respond. Thank you so much to Ishaan and Tim today. Great session. And again, thank you everybody for attending. This session is being recorded and we will post it to YouTube when we have an opportunity in the next week or two. So do look for it there. Thanks so much, guys, and have an awesome day.
Thank you, everyone.
Thank you.